ground fault interrupter receptacle detects a difference in current flow between the live and neutral conductors. When the difference exceeds a certain threshold, typically 5 mA, the ground fault interrupter trips to prevent electrical shocks. Electronic ballasts use a high-frequency current to power the fluorescent lamps. This high-frequency current can travel through the ground wire and create a small current flow to ground. Installing a fourth bulb may cause the total current flowing through the ground wire to exceed the threshold of the ground fault interrupter receptacle, causing it to trip. Firstly, consider installing a non-ground fault interrupter receptacle. Replace the ground fault interrupter receptacle with a standard receptacle that does not have ground fault protection. However, this may not be the best solution in a wet or potentially wet location such as a bathroom. Secondly, use a different type of ballast. Install magnetic ballasts instead of electronic ballasts. Magnetic ballasts do not generate high-frequency current, reducing the risk of tripping the ground fault interrupter. Thirdly, install an isolation transformer. An isolation transformer creates a separate ground reference for the lighting fixtures, preventing the high-frequency current from flowing through the ground wire of the existing circuit. Fourthly, use an electronic ballast with a low-noise filter. Some electronic ballasts include a low-noise filter that reduces the amount of high-frequency current that flows through the ground wire. Also, the wiring of the circuit should be inspected to ensure that it is properly sized and grounded. The ground fault interrupter receptacle may be sensitive to high-frequency noise. Replacing it with a different model or brand may resolve the issue. The installation of the fourth bulb may have changed the load on the circuit, causing the current flow to exceed the ground fault interrupter's threshold.